Today I'd like to share with you a game you can play with your children to help them learn mental addition strategies for 2-digit and 1-digit addition. Often we teach our children the algorithm method, but don't teach them how to computate in their head correctly. So here's a game in the materials you can do at home that help them to manipulate materials and see strategies and have fun while they're going. What you'll need is 2 hundreds charts, one for you or another player and one for your student. You will need MAB materials. You will need a strategy reminder. And you will need some cards that have got all the numbers 21 to 99. But you don't need the tens numbers. You don't need 20, 30, 40, 50, 60, 70, 80 or 90. But you do need 21, 22, 23 and so on. This is a rather large pile here and I'm likely to knock it over, so I'm going to take half away for now for the purposes of this video. You will also need a dice. I like a 10-sided dice because it has all the numbers 0 to 9 and I get more opportunities to use more strategies. You will also need some counters. We use one colour for one player and another colour for another player so that our children know whose counters are whose and we don't get any fights. So let's have a look at how to play the game. Now the object of the game is to turn over a card, roll the dice, add them together using the manipulatives or a mental strategy or both, and then you cover the number on your hundreds chart. And the winner is the first to get 2 or 3 numbers covered on the hundreds chart. That could be horizontal, vertical or diagonal. It's easy to start, when you first start playing, it's easier to work with only 2 in a straight line because there's a whole chart to cover here and you don't know what numbers you're going to roll. And then as you develop the skills and your child needs more practice or can develop that practice, do 3 in a row, but 4 in a row is too many. Okay, let me show you how we're going to do it. Let's say it's my turn and I've turned over 42. I roll my dice. 42 add 0. Well, 42 add 0, I add nothing, so I can cover 42 on my board. Now I'm going to keep playing as if I'm just playing with myself. If I turned over 86 and I rolled 0 again, let's try that again, add 2. 86 add 2. Well, my child should know that whenever I think of add 2, I just count on 2. So I could do 86, 87, 88. Or if my child needs a visual reminder, I can make that number using my MAB materials. 10s first, 1 second. So I have 86. I tend not to stick these together and line them up because the children need to subsitize. That means being able to see them no matter how they're laid out as a particular number. So it looks like 6 like that, but it also looks like 6 like this, and it looks like 6 like this, 2 groups of 3. Now I put out my 2 more, and I count on 86, 87, 88. So I can cover 88 on my board. And then I put this in my discard pile, and I roll another one. Now I'm going to set this up to show you how to do that different strategy. Let's imagine I get 27 and I roll a 7. Now are you noticing how I'm lining this up? I have my word 27 set out as though it's on a place value chart, a tens column and a ones column. And I'm lining my dice up ones under ones as though it's on a place value chart. This is helping my child see that algorithm later on. I'm setting them up to do the algorithm. And I'm saying to them, well, we have 27 and we're going to add 7. How are we going to go about doing that? Well, there are 2 ways we can do it. We can think of our strategies. We know that 7 add 7 is 14. So we could say, well, I have 20 and now I have to add 14. So here's my 20 and here's my 14. When I'm adding in my head, I always start with the larger number first. When I'm doing an algorithm method, that's when they're lined up on a paper. I start in the ones column first. And I make this very clear distinction with my students, or my children, and I say, if we're doing the algorithm method where they're all lined up and written on paper, we start in the ones column. But when we're doing it in our head and we have to think about it, it's easier to start at the larger number because that's how we say it. So let's have a look. 20 add 10, well, that's 3 tens, and 3 tens is 30. 30 add 4 is 34. That was easy. The other way that I could have attacked this is I could have said, well, 20, 7, add 7. So I'll get out 7 more, and I'll create another pile of 7. And all we're doing is looking for strategies that we already know. Now, I'll just quickly run through these. I'll do another video on these at another time. But when we add 1, add 2, or add 3, that's counting on 1, counting on 2, or counting on 3. If we add 0, we're counting on 0. This is for rainbow facts. They're numbers that make to 10. So 7 add 3, 6 add 4, 5 add 5, 10 add 0. This stands for doubles. This is doubles in 1 or doubles in 2. That's near doubles, like 7 add 6. We see that as 6 add 6, add 1. And this one stands for make to 10. That's numbers like 7 add 9. That could be a double in 2, or it could be a make to 10. You would take 1 from the 7 and put it with the 9 to make 10, and then add 6. We're just rearranging to make a 10 add something some. But we're not taking anything away or adding anything in. So I'm constantly referring back to these strategies with my children when I'm doing this. So let's get back to this sum. 27 add 7. Well, here's 27 and here's 7. Let's make to the next 10. I know that's 7. And for the purposes of this, I do stick these together. This is a wonderful addition to an MAB set, is being able to be stuck together. 27 add 3 makes another 10. That's a rainbow fact. So I used a rainbow fact with the number of ones that I had to make to the next 10. And I know that if I take 3 from 7, it's 4, because 3 add 4 makes 7. So I have 34. So I'm going to cover that on my chart. Oh, look at how close I am. All right, so now I'm going to take another card. And I'm going to roll, and let's see what I get. 32 add 4. Well, I'd be saying to my child here, remember turnarounds. It doesn't matter what order I add them in. I could go 2 add 4, and your student might have already remembered that that's 6. That's something they may have memorized already as a basic fact. But if they hadn't, you might like to suggest to them, well, I'm just going to change this for a 10. 32 add 4, there's my 32, add 4, is the same as 34, add 2. If I have 2, I can count on 2. 34, 35, 36, and I can cover 36. So you want your child to be able to get to the point where they can complete a sum like this one mentally and be able to say, well, 88 add 7 is the same as 88 add 2, add 5, or 80 add 15, because 8 add 7 is 15, which is the same as 80 add 10, add 5. When your child can do that mentally and you no longer need those materials, you know that they can work with these sums on their own. Have fun learning.